Ethan, I'm going to be looking at your paper 2 here. Controversies of modern vaccines. Modern vaccines have been around for decades now, and the way vaccines are produced is constantly evolving. Society has gone from the deadly polio cutter incident, the glitch in inactivating virus, and vaccine efficiency issues due to our current mRNA vaccines. Okay, wait. Society has gone from the one incident to our current. I think maybe what's confusing me there is I was expecting when the sentence starts, society has gone from this to that. But the first thing is an issue, a deadly issue. And the second thing you mention is not. It just says the current vaccines. Maybe also with what got me lost is that I think when you put that bit of explanation, the glitch in inactivating virus, I don't know where it ends. The glitch in inactivating virus. Oh, I see. So the other part is vaccine efficiency issues. Okay, well, now that I've gone through all that, I think that gives you help in taking it apart and put it back together. Okay. A lot has changed through the research and development of vaccines, especially during the past year when many records were beat surrounding the time taken to produce a vaccine that functions with high efficiency, as well as, I think maybe you meant to end that just with efficiency, with high efficiency. Do not, I'm just thinking about this right now. Don't be afraid to have simple sentences. You don't have to have all your sentences be super long and have all these like complicated pieces to them. In fact, some of them should not have complicated pieces. So feel free to just end things. Yeah. Okay, usually vaccines take 10 to 12 years to be developed and perfected, but the COVID-19 vaccine was produced in a mere... Sorry, I got paranoid. I'm not actually filming, but I am. It's all good. Okay. Usually vaccines take 10 to 12 years to be developed and perfected, but the COVID-19 vaccine was produced in a mere 10 months. Part of the landmark accomplishment was credited to the new mRNA vaccines taking the place of traditional vaccines. Many are worried about these new vaccines, though, and the ethics behind them when it comes to the research and development processes. With this, it is important to understand the differences between new and traditional vaccines, viewpoints about the vaccine and company developments. Wait, okay, so these are things it's important to understand. First, differences between new and traditional ones. Second, viewpoints. Whose viewpoints? Like public viewpoints? And then third is ethical issues leading to them. Okay. A little clarity there, but I think I'm with you. Before the recent months of using messenger RNA vaccines were only produced using a weakened or dead microbe from a pathogen to create an immune response. This way can now be known as the traditional way for vaccines. The immune system's response to the vaccine, small thing. So the response belongs to the immune system. So you need an apostrophe there, the immune system, apostrophe S, the immune system's response. To the vaccine, quote, aids in creating a member of the antigenic specificity of disease in the individual, thus immunizing the individual against that particular disease for a long period. Nicely integrated into your sentence. This method is an effective way to develop vaccines due to its reduced need for a booster shot. It's a specificity of disease for a long period. So does... Okay, we're still talking about the traditional way, I think. The traditional way, usually we don't need booster shots. Some vaccines do not need booster doses, such as flu viruses. You mean flu virus vaccines, right? However, many do not. The traditional vaccines usually have the least amount of side effects or relapse compared to RNA ones, I guess. I'm not saying you should add that. I think that's what I'm getting. There are a few ways that vaccines are made. Okay, well, so first this paragraph was about the traditional way to make vaccines. And now we're moving back to say there are a few ways that vaccines are made. Inactivated, conjugate vaccine, live attenuated, toxoid vaccine, and now mRNA. So that sentence sounds like it belongs maybe at the beginning of this paragraph. For many viruses, the live attenuated virus is the most common. This is the method the flu and smallpox have used. The live attenuated virus, quote, allows the host immune system to produce a primary lymphocytes for the antigens displayed in the pathogens. The issue with this type of vaccine is it is very slow to produce the lymphocytes in the body. Interesting. The type of vaccine used for hepatitis and polio is the inactivated vaccine. Definitely feeling like a new paragraph here. I really push people about, rearranging. I really push people about making their paragraphs shorter in my class. Understanding that writing for college, writing for your professors, they may be totally fine with you having these longer paragraphs. However, I think the skill of being able to create shorter paragraphs is extremely useful in writing after college, in your workplace writing, in most of the writing people ever do, because it's much easier for your reader, and it makes you more likely to have people actually read the stuff that you write, because they can look at it, and if it's just a whole page of like no paragraph changes, they're like, ugh. Anyway. So, yes, new paragraph, I think. The type of vaccine used for hepatitis and polio is the inactivated vaccine. This vaccine works by inducing an immune response in the host by using an inactivated or killed virus. Inactivated means it cannot replicate or survive in the host. However, there have been issues with this type, which will be talked about later with polio. I don't think you need with polio. That kind of confused me. It's okay if you just want to hint to us like there have been issues with this. We'll talk about later. Now I'm wondering like why you weren't talking about them right now, but you might have a good reason. We'll find out. The conjugate vaccine was used for pneumonia and meningitis. Yes. So maybe we're having a paragraph that's talking about. All right, let me just keep reading. Was used for pneumonia and meningitis, which is made by bringing a weak antigen, a strong antigen. This raises the immune system, the immune response to the weak antigen. Okay. So I'm wondering now at this point in the paragraph, I'm like, do you need to explain carefully like what all of these things are? If you're not going to really talk about them, maybe you just sort of mention them. Because I feel like you kind of open it up and I'm like, oh, what's that? And then you're just like, I'm not telling you anymore about that. The final type of traditional vaccines is the toxoid vaccine, which is used for tinnitus. Really? Tinnitus? Tinnitus? It is produced by the inactivation of endotoxins by chemical methods, including oxidation. With this type, booster doses are required. These vaccines are considered traditional vaccines because they have been available since the 20th century. Okay. Over time, these vaccines have been improved to increase efficacy and reduce toxicity. That's the reason they are still applied today. I mean, like used today, I think. In today's time, there are many new types, such as edible vaccines. What? rDNA vaccines and nanotechnology. But the main one we'll look at is the mRNA vaccines. Okay. So I guess looking back at this paragraph, I think you just need to revisit and think about how much do you want to talk about these traditional vaccines and how much do you want to, and which ones can you kind of like, are you not going to talk about much so you don't need to go into detail? Because I feel like right now the balance isn't great of like, every time you mention one, I was like, oh, tell me more. And then I was like, no, there's no more. Oh, tell me more. No, there's no more. That's me as a reader. Okay, mRNA vaccines are the lifeblood of the COVID-19 vaccines. It's exciting. You get to start a sentence with a lowercase letter, isn't it? It is to me. I don't know. I've definitely earned the hype. Sorry. They have earned the hype. These vaccines have not been seen until this past year. Unlike traditional vaccines that use a microbial protein or inactive microbes, its only component is mRNA strands. Okay. So another place, I'm like, if you want to talk about what microbial proteins are or what inactive microbes are, cool, go ahead and talk about it. But if you don't, then I would just focus on the part you are going to talk about, which I think is the mRNA strands, right? Because you're going on about that. Okay, mRNA is a messenger that tells your cells to make proteins. The COVID vaccines use messengers with instructions to make one portion of the virus that is harmless by itself. After the vaccine gets injected, the cells in your arm pick it up and learn how to make the virus protein, and your body learns how to make an immune response to it. I just had my second vaccine like a week and a half ago, and just reading this, it just blows my mind, man. Like I've thought about that since I got the shot. I'm like, this is what's happening in my body. It's just so hard to. It's amazing. Okay, there are quite a bit of advantages to the mRNA vaccines over traditional development methods, starting with the fact that mRNA is non-infectious and poses no concern for DNA integration. It cannot enter the nucleus, which contains DNA. Yeah, I've heard some of the people freaking out about it, being like, I can do that. And thank you for pointing out that it cannot. That was my understanding. Okay, but I'll go back a little bit. I'm feeling like you kind of changed subject with now I'm going to talk about advantages. That might need to be a new paragraph. Okay, sorry. It cannot enter, blah, blah, blah. With protein-based or inactivated vaccines, they need cell cultures to produce, whereas mRNA does not require inactivation, so there is no chance of contamination. I think I know what you mean. They need cell cultures. Well, no, I don't. Maybe what you're saying, and I think you can clarify this in revision, maybe what you're saying is that because the protein-based or inactivated, they start with cells, and so they might mess up what they do with the cells, but with the mRNA, they don't even start with cells, they start with proteins? I think that's what you're saying, but you do need to revise that a little bit to make it clear. This is very good for the medical world because many people still look back at the Qatar incident, which is a contaminated supply of polio vaccine that has paralyzed many. I'm glad you brought this up to me. I had never heard of this. You have educated me about it. Every time people have talked to me about, like, just personally about polio vaccines, they've just all been like 1,000% positive. I had never heard about this. Okay, anyway. That just tells more about who I hang out with. mRNA efficiency is also greater than traditional methods due to new technology that modified the molecule, increasing the amount of spike proteins produced in the cells. Modify the molecule, increasing. Okay. Another positive for mRNA is that it can be quickly scaled up, just as we have seen with COVID-19 vaccine. The COVID-19 vaccine. Why can it be quickly scaled up? How is that different than traditional vaccines? That I definitely want to know. These vaccines also cost lower. I think you mean they cost less than other platforms, or the price is lower. Why is that how we do it? I don't know. Making a desirable choice, however, these vaccines must be kept in very cold temperatures until they're ready to be used. Some of them, right? Because now we have some that don't. I think, as the mRNA will die even at low sub-zero temperatures. Okay. There's been quite a bit of controversy with the new mRNA. Okay, here we go. Specifically, so maybe back here you're talking about, maybe you need to specify, like, this first section is about the versions of the vaccine that were the Pfizer and Moderna. I think that's what you're saying, since you're talking now about Johnson & Johnson. There's been quite a bit of controversy with the new method. Specifically, the ethical issues for Johnson & Johnson is through the Catholic Church. I think it's the Catholic Church has an ethical issue about Johnson & Johnson. I think that's what you mean. On this day, the Roman Catholic Archdiocese of New Orleans released a statement saying that this Johnson & Johnson vaccine is, quote, morally compromised. Oh my God. The Catholic Church... quotations right there? Yeah, I guess they are. I feel like maybe just one word to tie that in. It's just quite unusual to have a quote in your paper that stands all by itself, because it doesn't really, then it's not really pulled in with the main body of your paper. So maybe just like one little word to introduce that. This was announced when, or I don't know, something like that, but better. The Catholic Church, go ahead and capitalize Catholic. That's a complicated thing. There are times you don't capitalize it, but you're talking about the specific institution, and that is capitalized. Denounces it because the vaccine uses abortion-derived cells in the development and production of the vaccine. The Church said that if people getting it have a choice to not do this vaccine. Many vaccine getters, however, do not have a choice, and this can lead to discouragement from getting vaccinated. In reality, though, the vaccine does not use fetal tissue, but embryonic stem cells were used. Moderna, Pfizer, and Johnson & Johnson rely on stem cells for laboratory testing. However, the reason Johnson & Johnson is scrutinized is because the stem cells were also used for producing it. Okay, interesting. I didn't know that. And since Catholics are anti-abortion, well, let's say since the Catholic Church is anti-abortion.